So this chart, and sometimes you come into an organization, and this is like in somewhat preaching to the choir. We all seen graphs like this, but I'm here as part of to keep reminding, and I do a lot of public speaking, and we just had a little discussion earlier. People have to understand how much society relies on fossil energy, how much it relies on coal for the things that are so important for the standard of our lives. Clean water, nutrition, food, education, healthcare, I don't care what you name it, industry, manufacturing, everything that's part of our quality of life has roots to this industry. And when you look at, if the U.S. is using about 97 quads of energy per year, right, and that mix goes up and down, right, I think that the strategy, and we say it, but we got to understand it, we got to get people to understand it and believe it. It is truly an all above. At any point in time on a curve like this, prices can fluctuate, which then means, coal becomes a much more important commodity. So we, in somewhat, are a product of our successes, and now it's about understanding and moving forward as we think about some of these things that are really important. So again, I know you know all this, but it's a common message and a common theme that I think it's important to keep echoing. This picture, I just like images, and the reason is because these are traditional images, coal, oil, power, and they're very traditional, but sometimes these traditional images are what we think about the past. It's almost what we think about the present and what we think about the future. And what I'm here to say is that we need to rethink this very mature industry that we're in, right? So we have this tremendous industry that has generated this prosperity for this country, and at the same time, we have to figure out how to create innovation. How do we penetrate new technologies into this existing coal-powered generation fleet that we have that's been so reliable for us? So our industry, and what I'm really pushing the researchers and the technologists inside the laboratory is, how are we going to do this? How are we going to build advanced energy technologies? How are we going to carefully reduce risk and allow capital investments to occur? How are we going to encourage investments in new technologies? How are we going to do this when we have an industry that has a low risk or low tolerance for risk, right? And has a 40 or 50-year cycle. So the things that somebody like me in a laboratory thinks about is when you have something that's a 40 or 50-year cycle, many of the engineers, and I know for sure inside the laboratory, may have one shot in their whole career to have exposure of taking a technology and actually integrating it into a large-scale system. And so this thinking about how do we ensure that we have the right talent pool to move these technologies is very, very important. So when we think about, GDP and, again, you see a graph, you've seen many of these GDP and power and energy consumption per capita. The real thing is we've seen many of these graphs and we know where we are, that there's a correlation between energy consumption and GDP, because energy produces product, it produces output, which makes countries economically sound and viable. The real question is, the trend is moving up, right? So you're going to have the same amount of energy consumption, but we want more GDP, we want more product, we want more value. And I say that the only way to do that is by innovation, right? How do we become more efficient in the power plants that we have? How do we get more out of the systems that we have? How do we create value from, the products, whether it's coal or natural gas, but coal, and how do we actually increase the GDP? And that's an important thing for all of us to think about, because at the end of the day, it is about the economics. So inside of the laboratory, I've really been trying to focus everybody's thinking in four specific areas. And in the center of that is this message that we have to keep putting out there. First of all, you have to have endurance, right? You have to have economic prosperity, and all of that happens because of energy. And it's a clear message to all of us, but it's not a clear message to everyone. And I think we have to, keep at this. So when I talk about secure and revitalize the energy infrastructure, we all know the impacts of the variations of resource, right? Whether it's a natural gas, whether it's hydro, whether it's coal, and the interrelationships. We had some great discussions this morning about what those interrelationships are doing to the existing coal-fired power plants and how it's stressing them, how it's putting, potentially a system that was never designed and it's running and operating at different operational levels. Of course, there's going to be, in the future, reliability. And so we're really trying to understand that energy infrastructure holistically inside the department so that we could create technology suites that allows this variation to occur. Now, if you move over to the right, I think it's very important, is this jobs and manufacturing. I mean, at the end of the day, right, you have energy, and that energy produces manufacturing. Manufacturing of products creates job, creates wealth, and economic growth. I say that it's not just about bringing, manufacturing back, but it's about the next generation of manufacturing, advanced manufacturing, manufacturing of new products maybe we haven't even thought about yet. So inside the laboratory, and we'll talk a little bit about it today, but if we talk about CO2 as a commodity, what is the value of that commodity? What could that value produce beyond the traditional things that we think about? We think about petrochemicals, we think about plastics, those kind of things. But we need to start thinking about advanced materials and those type of things. And so, again, we are spending time having a lot of discussions and looking at not only the return on investment of the technology, but how does that actually equate to the impacts of what we can see across the country. On the bottom right, about attaining energy dominance, and I really like this. We talked about energy independence. You see the shift of the language is about dominance. We have this resources available in the United States. That puts us at a position to be energy dominant. Now we have to come up with the strategies to help deliver that. But again, it's about using, the maximum use of the resources we have, valuing the commodity, and then looking at those future things. You always want to look at the future, right? And that's something like methane hydrates. And then if you move to the bottom left there, is just the value of the resource again. This value chain, you have these commodities, and yes, we can burn it for power generation, but what are the other values of these kind of resources that we have? Now, all the other bullets inside of those 4 boxes basically are things that the laboratory can help inform, shape, do, right? So, for instance, in the bottom left, right, understanding the technology, being able to do systems level analysis can help the department, and that's what we do inside the lab, to help inform energy policy. You've seen this chart probably a million times, right? It's just the way that we look at the coal program. And we have a coal program, we have these certain buckets, and I'll talk a little bit about more about what's in those, but I think what's important is, through what we're doing today, there's a big emphasis on commercialization, on how do we do things, how are we going to move things quicker? What are we going to do? I mean, we got to break this 10, 20-year cycle that we're on for technology growth. And so the laboratories being much more conscious, and I think you'll see this across all the national laboratories, a big emphasis on tech transfer, commercialization, and how do we actually move the technology forward. So when I look at the thrusts and, again, trying to penetrate with new technology in a low tolerance for risk environment, these are some of the things that we have to focus on. And you'll see the words are, more efficient, more cost effective, let's reduce water, let's talk about smaller, plant footprints, again, safety, all these words, right, are resonating. This morning we had a little discussion, and I thought it might be valuable just to kind of bring that discussion into the room for everybody in the audience. And we talked about, in the department, very clearly, I have a bunch of bullets, but they clearly wrote down and are thinking about 4 very specific areas. Having a much more efficient coal fleet, right? And what does that really mean, in terms of reliability, the ability for coal-fired power generation to dispatch quicker, right? The idea of, if you peel the envelope a little bit on the technology side, and it's embedded in one of those buckets, in our funding buckets. But it's really about bringing predictive maintenance so that you can actually repair things before they break when they're really costly. It's about controlling the systems a little bit different. It's about adding the idea of understanding large data sets of a power plant and being able to make decisions on them. And the reason I think this is important is a shift, because I think, at least I see this inside of the laboratory, is, we're great at energy conversion. We are tremendous at looking at efficient power plants. But now all of a sudden we're faced with interfacing data analytics inside of this big business that we have. We have to start thinking about reliability. And so what that means inside the laboratory is for us to reach out and partner with organizations who can help us advance the ball much more quickly than we would if we just had to self-learn some of these kind of techniques. And many of those things, like predictive maintenance, you see that in your automobile, but I think you're going to start seeing that real rapidly as we move forward with our agenda inside of the coal program. We talked about just the competitive nature of coal, both domestic and international, and how do you make it more competitive? Well, if you dissect our program, right, it's really about, how do we make the efficient energy conversion, something that we all know is a sweet spot, but is very challenging. And, people don't understand that. That's why I keep saying, power generation, and it's really a very complex system. And most people don't think about that. They don't understand that, and they don't understand the challenges of this. I introduced this idea that we need to start thinking about integration readiness, helping articulate maybe a different way to people about not only technology maturity, which is a very valid assessment, but also integration maturity. And so inside the laboratory, we're having those discussions and debates about how do we put that inside of our programs. The third thing is CO2 capture and making it affordable. Goes on to that, we got to keep bringing the cost down, making it affordable. If the goal is, less than $30 a ton, how do we keep driving that down? And so you're going to see, obviously the portfolio is going to be pressured to keep advancing and putting as stringent goals as we can, which will force us to be even more innovative. And then the fourth one is the sequestration. I think it's important, if we really believe that CO2 is a commodity, then we have to think about, how do we store it, how do we use it, how do we distribute it, how do we create a CO2 network. The modeling and analysis will be an important piece of all of that. Again, those are all pieces inside of our program. So when I say these thrusts and I highlight all these kind of words, you can bet that inside of the program, we're being very specific and conscious to try to drive towards those 4 goals. Now, I wanted to put up this chart, and I know you've seen these before, and it really, this doesn't, the technology really isn't as important as the philosophy of the R&D, but I think it's important for us as part of our messaging for people to understand that in early idea technology, it takes a good 20 years. And that's when everything is working, everything is lining up, everything is lining up. And so we have to be very diligent as we communicate the importance of how you mature technology and the responsibilities as you move forward into this commercialization. And I know you're all familiar with the model. I think in the future you might even see some integration readiness associated with this model. Then I think about what I talked about in the beginning, which is a lot of these advanced, systems, technologies, data analytics. It's gonna impact the workforce too. And so my only message on here is that as we think about that, as we think about new technologies, as we're thinking about commercializing, as we're thinking about doing these things, we should also be integrating a workforce component to this. And we should be doing that as early as possible in this, in this cycle. Because what I see, at least, the studies that I've seen, the interactions I've had, is, the energy sector workforce is really declined. I mean, declined in the sense of the number of people in that workforce. And so there's very specific, interest to make sure that we have the right people who are going to be able to support some of the, future power generation or any other kind of energy technologies. And you'll see inside of the department even support for programs like, Veterans for Energy, all of those kind of things. So I encourage you, if you have things that you want to engage on the workforce, please engage with us, because we're very interested to shape that as we go forward too. I put this up. I know Southern and, Roxanne, this will be a little highlight for this afternoon. But again, it's a message. And part of the message, as much as it's a great facility, my message is about its capability and the need for the capability. At some point, you have to do lab scale, bench scale, small pilot scale. You have to build confidence in the system. You have to de-risk. And that's what this capability allows us to do. We do that when we work with, with other companies. If we want to integrate technologies, it's all about de-risking, right? And so it's been an important asset for all of us. I think, from what I understand, there's been 41 in Roxanne, if I say any of this wrong, like about 41 major gasification test campaigns, over 29,000 hours of operation. It allows us to really, again, it's really about decreasing the risk. Another example, and I put this one up specifically about Petronova, because a little different model, not in the sense of the maturation line, but if you look on the left, where I have these arrows of technology maturation in industry, then government industry. So this is another way by which we partner, right? Sometimes industry moves technology forward, and then the government inserts itself at some point. And so, it's another good example about how we've taken, small technology, how we've been able to fully, integrate it, and then, of how it is coupled together in a very holistic fashion to be cost effective because of the linkage with EOR. From what my numbers tell me, as of September 17th, we produced over 568,000 barrels of oil. They produce about 2,600 barrels per day. I think it's it just shows the success of what we're able to do when we're linking some of these high technologies and thinking about it more holistically to make the economics work. I think there are things that we are learning from there, you know, and that's why you'll see us talking about programs, like, for instance, how much water we're using, hence why, you know, the idea of we need to really focus on reducing water. The fact that we are thinking about, you know, what else we can use the CO2 for to make that actual volume increase is really important. So again, just a tremendous opportunity for us to have learned through the scale. And every time we do one of these large scale activities, there's always learning. And you know, from somebody who comes from an R&D background, there's no such thing as failure. There's always about learning, experimenting, and moving the ball forward. And so some of these technologies and things we've been able to do have really made some successes. I know we know a lot about rare earths, but you know, talking about, you know, greater values of coal, I think, you know, it's a very important part of our portfolio. I mentioned it as part of this making coal more competitive and the diversification of coal. Many of you are probably pretty familiar with the rare earths and, you know, the fact that you can't, you know, that TV wouldn't be working, this projector and all of those things. Again, a common message we need to keep making sure we keep telling people the importance of rare earth elements and the importance for the U.S. to have some portion, or whatever portion, of our own available resources, so we're not bound by any international uses of that. So it's really tied to national security in a big way. But you can see just how much, you know, we consume. The global rare earth market, $5 billion in 2015. The U.S. consumes about 11% of that, and you can just see that there is opportunity again in this rare earth program, and it's gaining a lot of momentum because of the things that we've been able to do, and it really boils down to three areas, right? Enabling technologies, separation technologies, and then process systems. First of all, we have to know where it is. We have to characterize it. We're still doing a lot of sampling. As of the figures, we have over 1,300 samples we analyzed, and since 2015 and 16. We're improving the methods to do that. We've samples include coal, acid mine, drainage, tailings, different ash types, surroundings, and so we've done a lot of sampling in Pennsylvania, West Virginia, Kentucky, Ohio, Virginia, Texas, Alaska, and a whole bunch more. I think this is all informing and shaping the availability of this resource. We've actually been able to find where we have at least some places where it's over 300 parts per million, which then allows us to, use that and think about that, about the concentration. Again, a lot of work to be done, but there is a very strong program that is helping us kind of move the rare earths going forward. And this chart is a chart that, again, I put together, which I use to try to help articulate the things that we're doing. And inside the coal program and those initiatives, I just want to say them again because I think they're very important. How do we modernize the existing coal plants? If you want to use the word efficiencies, how do we make sure they're a viable resource? How do we get the most out of our coal resources, rare earths, new carbon materials, other uses for coal, other uses for, enable CO2 as a commodity for for energy security. So when you think about CO2, right, it's not just it's a commodity, but we need to start thinking about CO2 as a network. How do we move it? How do we transport it? How do we store it? How do we make it available to multiple industries? And then fourthly, how do we develop and deploy this next generation of coal-based energy systems? But the real thing is, those programs, those initiatives, those things we're doing in the department have those impacts, and I think they're worth keep repeating. It's about revitalizing manufacturing. It's about our global competitiveness. It's about energy dominance, and it's about economic growth. That is the why. Why we do what we do every day inside of the lab is to ensure a positive posture for all those 4 vectors and those impacts.